Okay, Rohan, whenever you're ready, you're good to go. Stage is yours.
Oh, perfect. Hello everyone. I'm pretty excited about this week because we are finally. So, if you have seen the series, week one, week two, and week three, in 3 previous weeks, we covered all the introductory level, or at least we tried to cover the basics of it. And towards the end of week three, we went into some more complex topics, but we still didn't really make an app that's actually cool. Roll a dice app, sure. We can roll a dice, we can roll a real dice. Random joke app, the jokes weren't even funny. Yeah, that's a big news that I have to actually say. We all knew it. The jokes weren't funny. The rolling the dice was boring. But this week, we actually are going to do something really interesting and have our X and Zero app or our tic-tac-toe game. And we're going to have a slight variation with it. So I don't know if you know this, but I am from LSU, Louisiana State University, and our biggest football rival. So in American football, our biggest rival is Alabama. So what we have done is this tic-tac-toe game is basically LSU versus Alabama, our biggest rival, and we kind of incorporated this match into the tic-tac-toe game. So the game will look somewhat like this. Yes. So each of the tokens instead of X and zero, they're actually going to be the logos of LSU and Alabama. And so you can play your moves and it goes from LSU, Alabama, the turns swap that way. And then when it finds a win, it grays out all the non-winning ones, like these four pieces, and it only keeps these one as completely opaque. And also then it doesn't allow you to play anything because you've won, right? And then you can press reset and start over again. So this is why it's so exciting and why you should be excited, because we're going to build, like, this is kind of like a real world app. So if you see here, it's like a table, like a grid. So we're going to learn how to implement that in Android. Behind the scenes, we're going to learn some complex programming concepts, or at least intermediate level programming concepts, like hash maps, and how we access elements from a hash map, how we put elements in a hash map, um, then how we devise the algorithm for figuring out if there's a winning combination on the board. So how do you figure out when someone has won? So we're going to think about that. Very basic, but this is the way of thinking is something new. And then we're going to delve into some slightly advanced coding concepts. So also, we're actually going to start doing our XML code. So far, all our layouts we have used the design editor. Now we're going to slowly sink our feet just a little bit into writing our code in building a layout in XML. So a couple of brief things. XML, the full form is Extensible Markup Language. So XML is very similar to HTML, but it's just a more lightweight and bundled down version of it. So it's not as heavyweight as HTML. Uh, both of these, they use the concept of tags, which we are going to heavily use in our layouts. So without any further ado, let us see how we are going to build our app. So yes, also this time we have implemented excessive amount of starter code and solution code. So that way it'll be much easier for all of you to follow along. So open a actually new project from version control and Git. So if you're already opened at your Android Studio project, you can go to new project from version control and then Git. So I'll click that. And now it'll ask you a URL. So I believe Yudesh has pasted the link. If not, uh, you can just go to GitHub and search my name. Let me go on a guess for you. GitHub. So all this code is on GitHub. So at any point you can download it. Just search my name, Rohan Kadkol, and go to users. So my name, then users, and then it's the first one. So you can click on this, and here you should find, so under repositories, it should be the first one because it's the latest one. So it's this one, the tic-tac-toe game. So you can open it in a new tab or whatever. Basically, we need this when you open this, the link that Yudesh must have put in the description. click on code, and then click on this link here, this URL here. This is how we're going to clone our GitHub repository on our local system. So now, once you've copied that, paste it here, and now it will clone it to our system. So just choose a folder of your choice. So let me just see if this is the folder that we want. Yep, this is the correct folder. So I click cancel. This is right, and then clone. So now it will open it in a new, yes. So I'm going to click new window, and voila! I mean your project is starting to get ready now. And even if you don't get all tick marks, as long as you don't get any explicit crosses, you're fine. So this grayed out thing is fine. And as usual, yeah, we're doing this for 3 weeks now. So I know the things is the size, the text size. Let's increase it to something bigger that people usually say that they can see much clearer with 14 and 18. So yeah, this is ready. And now if you notice on the bottom right where it says git master, so here is where you're going to choose which branch you want to do, you want to work on. So branches, even if you don't want to go into the jargon of git, basically branches, you can just think of it like what stage of your project you want to build on. So here, if you see, we have included one like a demo starter code. Master is the solution code. Then we've divided each of the starter code into multiple steps. So step one, starter and solution. Step two, starter and solution. So that way we have divided it into very small chunks, and I'm confident that you'll love it. It's really organized pretty well. So if you're on the master branch by default, you'll be on master. So remote means all the branches that are there on GitHub. So currently it has only downloaded the master on your system. So if you look at the usual things like app, Java, main activity, you see all this code is already written for us because this is the solution code. And if you see on app, res, layout, main activity, so you might have been in the design editor, design pane here. So it should look something like this. You see the app is done. But now we want to start from the beginning. So head over to Git and head over to starter code. So when you click on this and check out as, and put the same name in, starter code. So then what it does is, so let this complete. Oh, so this says, oh, so this has disappeared. Not a problem. We'll fix that. There's a reason why that's happening. We'll fix that. But anyway, this was the first starter code is just a demo. And also, I forgot to mention, you can always put in questions on the YouTube chat section, or if it's on Twitter, I believe, then on the Twitter chat section, and Yudesh will let me know when there's a question and I'll answer it. Cool. So here is a demo of a property called layout weight, which is what we want to use in our app today. So before we even begin our app, we're going to do a demo on this layout underscore weight. So to slowly start to understand XML code, let us head over, click on this, click somewhere else to remove it. Good. So far, we've just been building our layouts in the design editor. So if you are a design editor, so now we're going to see the XML code that's written behind the scenes for us by clicking on this text pane. So now in the text pane, you see all this code that was written behind the scenes for us. But now we're actually going to edit the actual XML code. So earlier, what used to happen is you used to use your drag and drop in the design pane. This is like a GUI, a drag and drop graphical user interface. And to change some attribute, you used to click on this and change it here. This is good, but it's not for the easiest way, actually. It seems anti-intuitive, but the easiest way is to go in the text pane and do it in XML. So we're going to do that now. So it looks overwhelming at first. Don't worry. We're going to go over it in some detail. So to explain how this XML is structured, let us head over back to our slides so we can see that. So Now, as we mentioned before, XML is heavily structured on tags. So as in HTML, you will have like a maybe like a H1 tag, there's a headline, like a B tag for body. Similarly here, there are some tags specific for Android. Now these tags come of two types. One is like an opening plus closing tag. So you open it and then you close it. And then there's one called self closing tag, which it closes by itself. Like you don't need two separate tags to open and close. Now let's see some examples of these two things. The first one is opening tags. So let's try to break down what this layout has. So this is an example. So opening tags, it basically just has like the Google, right? I mean, basically the less than and the greater than sign, or like the Google thing here, right? Basically, it's like a less than and the greater than sign. So if you notice here, a less than, and then what is the name of the tag, and then a less than. Between this, there are some properties that map to this tag. So our linear layout will be how much wide, match parent. What will be the height, how tall, match parent. So this is an opening tag. Opening, it always opens and closes. I mean, the opening tag, it less than, greater than sign, in the between, put the tag. And you can use this for parent tags, which we'll talk over later. Now, the next thing is basically the same code, but closing tags. Closing tags, they basically have the greater than and the less than sign, but instead of just at greater than and less than sign, they also have this forward slash. So the same thing as the previous page, but same thing as the previous page, opening tags, but it just has this closing thing. So why are we saying use it for parent tags? So this is an example of a linear layout, which so you may not be familiar with it, but linear layout, it structures the views in either a vertical direction or a horizontal direction. So um, from here to here is the opening tag. From here to here is the closing tag, right? Opening less than and greater than sign. Closing is less than and the slash greater than sign. Between that, whatever you put there are the children. So whenever you have a tag that will take in children, like a linear layout will take in children, right? So then you use the first type of tag, opening plus closing. So you open it, then in between you put all the children, then you close it. Open it, put all the children, then close it. So whenever you have children, be sure to use the first type. Now let's go into the second type, called the self-enclosing or self-closing tags. Use this for children tags. So for things like image view, text view, button, basically a text view cannot have any children. It is not meant to. So this text view is just the most like fundamental view in a way. You can't have children of it. So how does self-enclosing tag also starts with the less than and the greater than sign, but it ends with a forward slash. That's the only difference. So start and end it with a forward slash. And whatever properties are there between like within this the less than and greater than sign will map to this tag. So how wide is the text view? Match parent. How tall is the text view? Match parent. So this is what we're going to see in our demo now. So I'll head back to the demo. And if there are any questions at any point, you can be sure to put them in and I'll answer them. So here what we have is, even if you don't need to go into the in-depth of it, in this demo, we have a table layout, which is this table here, the first table. And again, this could seem confusing. Let's just try to understand the fundamentals of it. So here's an opening tag from here to here. Between this, we have this table row tag, and here's the closing tag. So table layout, it starts here in between other children, and then it ends here. So this table has just one row basically. You see this table from here to here, and this has one row. Now, why are we even talking about this, Rohan? I mean, this doesn't look even like the X and Zero app or the tic-tac-toe app. Well, we need to learn an important concept here called layout underscore weight. So within this row, how do you want to space the children? So if you notice here, the width of each of these children are the same. How is that happening? We specified a layout weight to each of them as 1 to each of the children within the row. Again, I'm pretty sure it might be confusing, but like don't look at the complexities of XML. Let's just try to understand the fundamentals of it. And if there are any questions, feel free to put them in the YouTube thing, in the chat section. So if you give each one a weight of 1, it spreads it out evenly. Now, let's look at the second table. So the table ends here, the first table. The second table starts from here. From here to here is the opening tag. Then everything between this is the children. So it has one child called a table row. And then here's a closing tag for that table. Now within the row, there are 3 views. Now if you notice here, these image views, right? This, and this. The middle one takes, the weight is 2. That's why it takes much more space. So what Android does is it adds up all the weights. So 1, 2, 3, 4, and then it divides them in 4 pieces. And this one gets 1 piece, this one gets 2 pieces, this one gets 1 piece. So this is just something to notice here. Let's look at the third one. Third one, it is 5 plus 2 plus 3. It is 10. So it divides this whole width from here to here in 10 pieces, and then it gives the first image view 5 pieces, the second image view 2 pieces, the third image view 3 pieces. So at least if you understood the broad view of what weight is it specifies how many pieces it gets when you divide it. So at least the abstract level of it, not the in-depth, that will be fine. Best to always connect the charger quickly. Yeah, we shouldn't lose our work. All right. Now that you've seen the demo, there's one thing. So if you don't see that git master thing at the bottom right, it's fine. There's some problem here, but you can head over to the terminal. So this is something new, which we won't even deal with too much. So don't worry. Just type in your git checkout master. Git checkout master, and then click enter. Hopefully, if you click out here, you should get this back, and it should get back to the actual code. So that was the demo. All right, so now let us head over to our first starter code. So step 1, starter code. So again, on the bottom right, this git master, click on it, and under remote branches, so the branches on GitHub, now you have only downloaded these 2, the first 2. Download step 1, starter code. Check out as, and same name. And now, if you notice here, so again, if you don't have these tabs open, app, Java, package name, main activity, there's this one, app, res, layout, and activity main.xml, which is this one. So now, instead of doing it in design, we're going to actually implement our stuff in text. So this is a table, right, which is going to be a table for, let me show this table here, right? We have this table. There are 9 tiles here. So let's build that now. So that is the first step. So currently, if you notice, there's just 1 row in this table. So the reason why they starter code is so we don't have to deal with the in-depth of it. Let's just try to understand the abstract part of it. So within the table here, here's the opening tag from here, and it ends here. It just has 1 row within the table, which is this row. We need to add 2 more rows where each row will have 3 views, right? So 3 rows with 3 views each, so 9 views. So basically, just copy this whole thing and create 3 rows. So already 1 row is created for us. So let's copy everything. So we haven't even coded as such. We're just copy pasting just to understand, slowly get a feel of it. So copy everything from the opening of table row to the closing of table row, Ctrl C, and paste them here in this to do. Create 2 more rows. So Ctrl V, first one. You see now there are 2 rows here, and Ctrl V. Enter, Ctrl V. So if at any point you're stuck, you can head over to GitHub, and here under branch, you can select step 1 solution code, app src. This is an easier way, but I'm just showing you now quickly. Main res layout. So if you want to remember the path, you can see it here. App src main res layout. And so you have the path here, and the solution code is here. So you can refer it in at any point if you want to. So be sure you're on step 1 solution branch and this file. Well, let's head back. So we created 3 rows now. Now we get all these errors. The thing is, let's scroll all the way to the top. This table layout, the first row, the first view. You see it, Android has highlighted the first view. They've given it an ID of 00, then the 01, and the 02. Basically, this is 00, 01, 02, and there should be 10, 11, 12, 20, 21, 22. That's going to be our scheme, right? It's just like a 2D array, right? In a 2D array, you have 0, 0, 0, 1, 0, 2. Or in a matrix, in mathematics, the differential equation, the matrices, right? You have, I think there it starts with 1 index. But in computer science, everything starts with 0. So scroll all the way to the top. The first row, the ID is iv underscore 00, 01, 02. Here, change the ID for the second row's first row. So you can click on it here, or you can scroll to the top. Here's the first row. Here's the second row, the first view in the second row. Change this ID to 10. This gets 10. It should be 11. And this should be 12. And those errors should go away. Basically, ID should be unique in the entire document. Now, scroll down to the third row. So if you click on it here, it even highlights it here. You see a small blue outline. So you have this row here. Now, each of its individual views, change the ID to 20, 21, and 22. Very good. So now we have completed this to do. Basically, we didn't even code as such. We purposely did this so you don't have to. Let's take our time in coding in XML. We just did copy paste for now. And if you notice here, these weight attributes. So if you go in any row, you check there's weight, weight, weight. Each of them are given 1. Hence, they are divided equally. The width is divided equally, and each view gets an equal width. Right? And yeah, so that's the thing. So this weight property here. And also one thing that we have done here is on click of, so each of the image views, the on click of each of the image views are pointing to this method called on tile click, which if you head over to main activity, there's some code here for us. Basically, it points to this method here, on tile click. So whenever tile is clicked, the on tile click method will be called. And here we're going to write the code such as, change the image in the image view, right? So when you click on the tile, the image should be like the LSU logo or the Alabama logo, and it should check if has anyone won the game, So many steps are there. So we actually completed our first thing. Our first to do here was add 2 more rows. We did that. Each of the tiles, they point to this method here, on tile click. So if you notice, each of these image views, they have an on click attribute, on tile click, which is basically this one, on tile click. So that actually completes a third to do. So add the on click property to all the tiles. Now the second to do is, this is basically from weeks 1 and 2, all we're doing here now. So if there are any questions, you can see those videos. Find view by ID. So if you notice here, we have all these image views variables for each of the 9 tiles. So 0, 1, 0, 0, 0, 0, 1, 0, 2. 101112 202122. So they're currently not initialized. How do we initialize them? Correct. In on create, we have to use find view by ID. So MIV00. I'll do the first one. R.id. And if you head over here, basically this view, right? It has an ID of IV underscore 00. So you're hooking up you're linking all the XML views there in our layout to our code. So again, so if this seems new to you, don't worry, you can see the weeks 1 and 2 videos here, IV underscore 00. And similarly, initialize all of these too. So from 01 all the way to here. So MIV01 and view by ID R.id.01. So if you ever want to autocomplete, you can click Control space and it helps you out. So 01 is what you want. Now to save time, one shortcut that we can do is Ctrl D, which duplicates the line. So place your cursor on any one of these lines, Ctrl D. Notice it duplicates the line. So we need 9 of these lines basically. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, all you have to do is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, then 2, 0, 2, 1, 2, 0, 0, 1, 0, 2, 2. I think I pressed the function key, which is linked to the music. It's a mute button here. 0, 0, 0, 1, 0, 2, 1, 0. Any questions there? You can place it in the YouTube chat section. 2, 0, 2, 1, 2, 2. All the warnings should go. That completes our second to do. So let me run like what we did here. We added 2 rows by copy pasting the first row. First row was an example row. It has all these attributes that you can go over at your pace. Maybe later or I don't want to overwhelm you already. We just started with XML coding, so let's go slow. Basically, each of the image views have this source thing that points to. Under drawable, we have these logos here. So it just points to any one of these 4, right? The logos. So yeah, you can go over it. So we just added 2 rows, and here we initialized all the Java variables that we have in the starter code. And on tiled click, we linked for each of our image view here in the on click attribute of that image view, we passed in this on tiled click here. So we completed our third to do. So that's it. You can head over to. So we completed our first step, step 1. And if you make some mistake or you want to go to the next step, you can just leave it as it is, and maybe it will give you some error. Let's see. Head over to step 2, check out as new branch name. What will happen? Yeah. So check out stats then. So your local change will be overwritten by checkout. So one thing is if you want to save the work that you've done, which you can or you don't want to. So head over to version. Will this be okay? This will be too complex. So if you want to save your thing, you can actually come here in the terminal if you want to save it. So you don't have to save because this step 2 starter code will it will like have the solution of step 1. So if you want to save, type these lines of code here, git add dot. So this is basically like a simple like git command. So we don't have to go into what this is. just we can type this in git add dot git commit dash m, and in these inverted inverted commas, here you can type in just any message, basically. My work, or my work for step 1, anything basically, and then enter. And these green lines should disappear then. So yeah, and you see something like this. Green line should disappear, and now you can switch. So basically, it said that do you want to save your changes or not? That was the error that we are getting. So now we save the changes. You can head over back to step 2 starter code. So if you want to check the solution code, you can do that too. So again, everything is on GitHub. Now we can head over to step 2 starter code. Check out as, and okay. And if you notice here, you can minimize this pane here at the bottom. Notice the solution is from previously is there because we have already done the solution. So, and here we already have our 9 views here. Well, now here let us see what are the to-dos. So now when the tile is clicked, so now we're actually going to do our Java coding. So this, I'm sure most of you might have some experience with it, because Java or any object-oriented language is what we learn usually in the beginning of college or of high school, maybe if high school students are watching this. So let us start to do our coding here. So on tile clicked, since in our each image view, the on click method is on tile clicked. So basically, whenever a tile is clicked, this method will be called. So whenever the method is called, we have to do some work. Let's do that work now. First to do, store the clicked image view ID in a variable. So the image view's ID, the int ID is equal to, so whenever, like whichever view is clicked, so if this image view is clicked, if this one, or any of these 9 image views are clicked, when it calls the on tile click method, it actually passes itself here as a parameter. So what we can do is just view dot get ID. So whichever view is clicked, it will be passed here. Basically, we are saving the ID of that view in this int variable. So let's say if this was clicked, then what's the ID of this view, this image view? Click on it and it highlights it in the code. The ID of that is IV_11. So this ID_11 will be returned by get ID, saved here in this variable. So all XML IDs in Java, they're stored as integers. So there's not like an ID type or something, like an ID or something. It's int. Simple. Second, so if you notice at the top, we have this is board active. So basically, if a person has won the game, then is board active should be set to false. So no more inputs are accepted. So what we did here was, we have to just check if the board is board active. If it is not active, then basically don't do any work. Don't return. It just exits this method. So if the board is not active, exit. Now this is another case. Let me head back to our GitHub. A screenshot here. You can head over to my your repositories. I'm going to show you the screenshot here. So basically here, now what the user has clicked this button. What if the user again clicks this button? We shouldn't. So we should only accept inputs when the user clicks an empty spot. Empty spot. So how do we do that? Here, if you do another thing, or board. So let me explain what this board is here. We created at the top, we created this enum. So if you don't know what enum is, no problem at all. Just think of it like a category. So a team could be of any of these 3 categories. It could be LSU, the token could be LSU token or Alabama token or empty token. And whose turn it is saved in this turn variable. So it is first LSU's turn, then it will be Alabama's turn, LSU's turn, Alabama's turn. And we're creating this 2D array of this enum type. So it could get complex. Be sure to put your questions in. And if you always want to refer the code, always on GitHub. Solution and starter code is detailed there. And feel free to ask me any questions too. So we created this board, this 2D array board, where it like corresponds to each of, like you see 9, it corresponds to an actual board, right? So we start off with all of them are empty. So here we can check if board 0, 0. Let's imagine if 0, 0 is pressed, right? If this view is clicked, 0, 0, then this, if it is not equal to empty. So basically, if the board is inactive or if the user has already played something there, so then return. Now the thing is we are assuming that only this view is clicked. That's why we put 0, 0. The problem is, now what if now this view was clicked? We have to check 0, 1, right? According to our IDs. So okay, I think this is getting confusing. So basically what we have to do is head over to to-do 3 and create something called a hash map that maps each of our XML's ID with the indices. So this one should map to 0, 0. This should map to 0, 1. So basically, it should map to integers. So I'm not getting any questions. So I'm pretty sure people are, it's too complex. Be sure to put your questions in because I want to explain this properly and make the most use of, if you're attending this, make the most use of it. And so I don't know if people are understanding, people are not. Yeah, I'm just going on. If anything, put it in the chat section. If any questions. So now, what's a hash map? A quick view on what's a hash map is here in our slides. A hash map is basically a group of key value pairs. So think of it like the social security number and the person's information, right? Like if you go to the social security office, I can ask the key. I can give you the social security number, and in the official's computer, all the information linked with that key is given. All the information is the value, and the social security number is the key. So we have these key value pairs. That's basically what a hash map is. It's this combination of key value pairs. So whenever you want to get some value, use the key to get that value. And also be sure to understand that order is not maintained. So a linked list, it has like a proper order. An array, it has a proper order, right? Like 0, 1, 2, 3. In hash maps, the order doesn't matter. So behind the scenes, it could be implemented in any order. So something to note. Let's look at an example of a hash map. So a hash map, it takes in, this is a generic type. So it takes in 2 generic types basically. The first one is what is the data type of our key. The second one is what's the data type of our value. This is the variable name is equal to new hash map, just the usual thing. And even if you don't want to remember all this, like, the less than greater than sign and then the parentheses, just the autocomplete will help you out. It's not a problem. Now this is important. How do we put entries in our hash map? You can call the hash map's name dot put, pass in the key, pass in the key over here, comma, then pass in the value. So keys of integer type, values of string type. Also, since it's a generic, so it has to take classes here. So you can't pass in int, the small int, to pass in the like integer, the class variable. I mean the class of that fundamental data type int. Well, yeah, I don't want to confuse you more than you must have already been. So let's go slow. So key value. So call the map dot put key value. Now when we're going to extract values from this hash map, you can just do .get on the hash map's name, so .get, and then here pass in the key. So when you pass in 1, 2, 3, 4 on this hash map, what's the value associated with that key? Steve. So Steve is saved here, name 1, Steve 7890. If you do .get 7890, it looks in the hash map. Oh, I found one with this key. So return the value. .get, it returns the value. So Samantha will be saved here, name 2. If you pass a key that doesn't exist in the map, it'll just return null. So null will be saved here in name 3. So this was just a quick introduction of what hash maps are. Let us start to implement it in our app. So where it says to do 3, basically what it says is the key should be of type integer and a value should be of type image view. So let's just make it, let's see why we're doing this. So hash map, you can keep it private if it's good practice, keep it private. Key is of type integer. Our value is of type image view. Let's call this hash map what they have said here, mid tile map is equal to new hash map. So I'll go slow here. So we created this hash map of key types as integer. The value types are image views, which is one of these. So now it will be much more clear when in to do 5 we write this. So basically what we do is we take mid tile map. So why do we name it mid tile map? It takes in the tile as the key and id as the key and the tile or image view as the value. So again, I'm just going forward. Any questions there? Put it in. So tile map dot put. So let's populate this hash map. Then we'll know exactly what are we doing here. So r dot id dot iv00 iv00. Let me do 3 of them. Then you'll understand what are we doing here. I'll do one more. Ctrl D, and now I'll explain what I did. So this id tile map, it takes an integer and value is image view. So basically we mapped the IDs in XML, right? In XML are iv underscore 00, iv underscore 00. So the key, we pass that as a key. The value is our image view, right? This image view here, image view here. So we basically, now whenever we call on this map, we call dot get and we pass in this, it returns the image view associated with this ID. So now let's we did it for the first row. We have to basically add all the 9 IDs here, all the 9 image views here. So Control C, paste it here, paste it again, and 01, 02, 10, 11, 12, 20, 21, 22. Now, for each of the corresponding IDs, let us have a for each of the corresponding IDs, let's pass in the corresponding image view. So for 00, correct image view, 01, 02. Here, since we copy pasted, let us change all of this. So 10, 11, 12, 20, 21, 22. So we populated this MID tile map. So the keys are the XML IDs, as it says here, XML IDs. The values are the Java image views, as it says here, Java image view variables. Now let's do the same thing for here. So as I said, this could get a little like it's very going to the intermediate level of coding now. It's good practice, and you can take your time. May not even be code along with me. Just watch what's going on, try to understand, and then at your leisure, at your time, you can follow along with the very detailed start and solution code. Well, all right. private. Here now we have to create another hash map according to our to do, which again takes in our XML ID as the key, and as a value it takes in an integer array. So we'll see why this is. So key is this, and is an integer array, well, not int, but it's a capital integer with 2 indices. So we'll talk about what that is. Call it MID index map, as it says here. Right? And I have to do everything's detailed, so you won't have any confusion. New hash map. To 4. To do 6 is populate this hash map. So let us populate it. So basically, it's okay. Let's do MID tile map. Sorry, index map. So the first map was to map the XML IDs to your image view. Now we have to map the XML IDs to our integer indices. So let's see what that means. It'll be much more clear now. Put IV0. So this is the XML ID. Map this to an integer variable, an integer array. Let's see if this works. If not, if we change it to capital int. Yeah, or let's change it to capital integer. So basically 0, 0, or 0. So basically we are saying like if we get 0, 0, it should return us 0, 0, the actual integer values. So like a string kind of thing, right? I mean, this whole thing, oops, this whole thing will return an integer, but at the end of the day, this is a string basically, right? So we link the string with actual integers here, 0 and 0. So now if we ever want to know what the indices of this image view, we can just call it on this hash map and we get it. So MID index map dot put r.id.iv. So I'm doing it for all the tiles. A new integer and 0, 1. There's a mistake here. The curly braces for initializing. Now to save that, okay, I'll do one more. Let's do. So I'm linking the XML ID 002. Quick question, what that is 02? In matrix 01, I mean 00, 01, 02. So basically I'm linking this 02 with 02. So I hope it's clear. I'm trying my best to explain. So I know people might be thinking that, well, it's so complex. Trust me, it's not. It's just new. So because I'm not receiving any questions. So that means either one, you understand everything really well, or two is people have tuned out, which I think is the second option. It usually always is that. So, well, I mean, I hope it helps you in some way what I'm doing, and I mean, I'm opening myself up for questions, and I hope I can help you out. So 1 0 1 1 1 2 2 0 2 1 2 2. Okay, good. So 1 0. So let me complete this and I'll explain what we did. Basically, it's the same thing as what we had planned. So here in our first hash map, we put the ID, XML ID, and then we put the image view. In our second hash map, we put the, again, XML IDs, and for our value, we pass in the two integers like 0, 0, 0, 1, 0, 2, so on and so forth. So whenever we receive an ID, we can know what the indices of that ID. So why are we doing that? Here, it will help us now. The thing is, this ID is currently of the form of like something like this, r.id.iv22. But the thing is, in our board 2D array, we have to, in a board 2D array, we have to pass in two like integers as our indices. So let us get those integers. How do we get that? The reason why we created the hash map will be clear now. Integer array called, let's just call it indices, is equal to, now MID index map dot get ID. So what do we do here? From that index map, we remember we pass in the key, then we get the value part of it, right? So what we're doing here, this ID, as I mentioned before, is of the type r.id.iv22. IV22. So when we pass the ID that's of that form, it looks in the hash map, finds, let's say if we pass in IV11, it finds this, then it returns this to us here as the value. It returns it here. So we get this array here of indices. Now here what if you do is indices 0, indices. So we can ignore the warning now. Why we're doing 0 and 1? Basically, indices 0, it points to the first index here in this index array. Indices 1 points to the next one. So that's our plan. So now we are saying if the board is inactive or if the board isn't empty, I mean that particular point that the user has clicked isn't empty, just return. And if it is, so if it is not empty, so if it is empty, then you have to put a token there, right? If the user clicked an empty place, you have to put a token there. Let's see how we do that. So now to decide which image to display, int image is equal to, again it's int of type int, m turn. This is our current turn basically. If you say the current turn, if it is equal to, the current term is LSU, so this is a ternary operator. If the thing is LSU, then r dot drawable dot LSU logo. Else r dot drawable dot Alabama logo. Will this work? Okay, it works. So this is actually an integer behind the scenes, so save it here. So if the turn is LSU, then LSU logo should be saved to image. If it's not LSU, then it's exclusive, right? So it can be only either one, it cannot be both. So we can just say if it's not LSU, then it has to be Alabama. So return the Alabama logo here. Now, to whichever view was clicked, we currently only have the ID of this form, right? Of this form. Now to get the actual image view, to set this image in that image view, we can use this hash map. We have the key, get the value with it. So MID tile map dot get ID dot set image resource, pass an image. So this basically, this line of code, it returns us an image view. Which image view? It's determined by whichever is the image view associated with this ID. So from here it checks. Maybe if let's say 20 was clicked, we pass an ID 20, no, yes, match. So it'll return MIV20. It's returned here. Then, as we discussed briefly in weeks 1 and 2, is you can call dot set image resource. This specific method is new, but it's similar to dot set text, right? Set image resource here, but we determine the image, we pasted it here. Update the 2D array board. So if we go to our board, and indices 0, indices 1 is equal to m turn. What does this mean? That means in a board now. So let's say if 10 was clicked, then change this team empty to team whatever is the turn. So if it was LSU's turn, then put LSU here. So this will change to team.lsu. Change it back. So that's the point. So our board 2D array is how we model the layout. So here we know, like at any point I can say what is board 0, 1. 0, 1 is this. So what at 0, 1, so the top center, which token is there? Empty. That means no tokens there. If it was team.lsu, LSU's token was there. You see what we're doing? Board is how we're doing it in code. Well, next to do, check if anyone has 1. So you can just call check 1. Is this method here, which you're going to implement soon. And let's pass in our ID. Finally, update the turn variable. So currently it was m turns turn. Yeah. So now it has to go to the other teams that turn, right? So you can do m turn is equal to m turn is equal to, let's type in LSU, the autocomplete does it for you, team.lsu. So if mturn was team.lsu, then this mturn should be equal to Alabama. Else LSU. What does this mean? If the term was LSU, then you have to change it to the opposite one, right? So change it to Alabama. If the term wasn't LSU, that means it was Alabama. So change it to LSU. Yeah. So that's pretty much it. Not pretty much it. That is it. So 10 to dos. Head over to do. Yes, we completed all 10. So the 10 to dos here. Quick brief view on what we did in step 2. We learned a little bit about hash maps. So you can take your time at your pace and refer to some resources. And the code is I've tried to make it as detailed as possible. So I hope it helps you out. We created 2 hash maps that maps each of these integer IDs to first hash map maps it to the Java image view variable. Why do we do that? So we can set the image resource here. Else we have to do long switch statements. So this is good. We're just mapping it. It saves us lines of code. I'm directly giving you the why you came here, the professional kind of coding thing. So don't blame me that I'm doing hash maps. Like, why doing hash maps, man? We can do switch statements. Yes, switch statements are more common. I mean, everyone might know switch statements. Hash maps is something new, and some people might even know hash maps. I don't know how the audience is because no questions are coming in. I can't gauge how the audience is. Well, I'm just hoping everything's fine. Then we create the second hash map is we take the XML index and map it to the 2 integers associated with it. Good. Then on an on tile click, when the tile is clicked, we remember I said whenever a tile is clicked, it passes itself as this view parameter here. We extract the ID of that view parameter. So let's say if this was clicked, what's the ID of that? IV underscore 11. So view.getID will return IV underscore 11. So r.id.iv underscore 11. Then we get the integers out of that. So this is equal to IV underscore 11. So index map. So IV r.id.iv underscore 11 match. So return the value is this. So it returns 1 comma 1 in this indices. So now you can do board indices 0 which points to 1 and board indices 0 which points to 1, board indices 1 which points to this one. And then we just checked if the board is inactive. So if someone has already won, don't do anything when a button is clicked. And here we check if somebody clicks on a token that's not empty, then just escape. Right? Not empty, escape. Then we checked which image, if this checks pass, then which image to put in that tile, and we set the image resource. Then we updated a board 2D array to be equal to which token was placed there. Then we did a check one, which isn't implemented, but it basically checks if someone has won. Then we change the turn, like it's the next person's turn. So we change it. Good. To save it, you can save it, or if you don't want to save it, no problem. If you don't want to save it, just I recommend just save it. It's better if you save it. Git add dot. Again, git add dot. In the terminal pane, git add dot enter. And git commit -m. Let's type in any message. So it could be something like my work for step 2. Not really important, but message doesn't matter too much. Enter. Git commit -m enter. Now the green should go away, so the changes are saved. This means like what are the updated lines? Let's click here outside the terminal and it should go. Now you can head over to our step 3 starter code. Check out as. So we're downloading it from our GitHub into our local system Check out as, same name. Let Android Studio do the magic for us. Now if you notice, the solution code is like it's already done for us. The previous step solution code is already done for us. Now let's see what is the new work. What's the new work in step 3? Yes. So now we're going to start to implement check 1. So in order to check 1, now we get to our next step in our slides, which is winning combinations. So in our XN0 app or our tic-tac-toe app or our LSU versus Alabama app, go LSU. And in the spirit of LSU. I'm wearing the LSU shirt. It's the only LSU shirt I have. We got it on a freshman year, and during a freshman year. So it says, I don't know if you can see it. It says first year experience. Yeah. So it's LSU versus Alabama game is very hyped. It's really entertaining, and we all root for LSU. Well, winning combinations. 8 winning combinations are there. 3 horizontal, 3 vertical, 2 diagonal. What Rohan means, I don't know. Well, let's check it out. Basically, in our winning combinations, if you think about it, it looks like there are 9 tiles here, but at the end of the day, there are just 8 winning combinations. It could be 3 horizontal, like one, two. This is the third combination, and there are one, two, here 3. Then there are 2 diagonals also, one, two. So 3 horizontal, 3 vertical, one, two, three, and then 2 diagonal, one, and then two. So totally there are 8. 3 plus 3 plus, when I got previous slide, 3 plus 3 plus 2, 8 combinations. So we don't have to check the whole board and make it complex, and we basically need to check in any of these 8, are there 3 matching tokens. So we'll check this combination first. LSU empty empty, no win. Then check maybe the next horizontal, empty empty empty, again no win. So it has to be all of them have to be equal, and all of them have to be not equal to empty, right? So it has to be like LSU 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 or something similar. So we need to check all these 8 lines and just check if the tokens are the same and if they're not equal to empty. Cool. Now, what do these arrows mean? The thing is, you don't need to check actually all 8 at all the times. So this is where efficient algorithm design comes into play. Well, it's not exactly too difficult to think about it. With time, I'm sure you also would have got it, but it's just good to know some efficient tricks. So when you click on this token here, the only combinations that you're changing are, one is this vertical one, then is this diagonal one, and is this one. Because you don't have to check, are these 3 equal? Because when you change this token, it doesn't change this anyway. So only check this one if all of them are equal, if this one, if all of them are equal, this one, if all of them are equal. You see? So now instead of checking 8 every time the board is changed, we only check 3 in this case. Right? Because only these 3 lines will be changed. Now, in this one, there are only 2. Like one, like if you change the token here from empty to, let's say, LSU, you are only changing this line of the winning combination and only this line of the winning combination. The diagonals, if it was lost, will always stay lost. If this was lost, will always stay lost. Same with this, same with this. You see? So we only check 2 now, which is more efficient. For here we check 3. So like you can think about it. What about if someone puts a token here? How many combinations you have to check? Now this is our only like maximum of inefficient thing here is we have to check actually this one, because the middle one, the middle tile, it belongs in this vertical combination, it belongs in this one, belongs in this diagonal, belongs in this diagonal. So we have to check 4. That's it. That's how we check if someone won. So let us, yeah. So that's actually the end of our slides there. So in check 1, so here if you notice there are 3 methods created here, which, so just to make it much more easier for you to see what's going on. So there's even a helper method called R3 equal. So basically this helper method R3 equal, if you scroll down, that's again Java docs. As I said, each thing is documented to a fairly good level. Generics, if you don't know generics, not a problem, just ignore it. Basically this method, it checks if all the 3 pass parameters are equal and it returns that. So if A is equal to B and B is equal to C, that means all are equal. So it returns that boolean. So what we did here in horizontal 1, let me head back to the slides actually. So the jargon that we're using here is, I don't know why this is not going. All right. So we call this horizontal 1, this winning combination horizontal 2, this winning combination horizontal 3. This is vertical 1, vertical 2, vertical 3. Since this is the major diagonal in mathematics, so this is diagonal 1, This is diagonal 2. Basically, we're just giving some codes to all our 8 winning combinations. So horizontal 1, 2, 3. Vertical 1, vertical 2, vertical 3. Diagonal 1 and diagonal 2. Good. So here in our horizontal one, how to check if someone has won. So this returns a boolean. So this is again in the static code, so we are not implementing these. For horizontally, we're not implementing. So it checks if all the three are equal. So horizontal one, what are the three indices that belong to horizontal one? Let's check. This is horizontal one. So 0, 0, 0, 1, 0, 2. So are these three equal? Right? Are these three equal? And then if they're equal, so this is within the if statement, we have to call this method called one, right? That takes in the three XML IDs, so 0, 0, right, 0, 1, 0, 2, and we're going to implement this. But basically, our three winning IDs, we have to pass it here, and it does some stuff, which we'll implement in a later step. All right, so we have to implement in a later step. And if someone has won, so it calls this one, it returns true. If it hasn't won, it returns false. So I think you must be getting the idea of it, at least in general. Let's see how we're going to do for the other ones. And to do, we have done only for horizontal. If you do now for vertical 1, 2, 3, and diagonal 1, 2. Let's do it. So you can copy one of these methods, Ctrl C, and paste it below these to dos, and rename this vertical 1. So we'll see what it means. So R3 equal. So what are the three things in vertical 1? Let's head back over to our slides. This is vertical 1, right? So what are the indices? 0, 0, 1, 0, 2, 0. 0, 0, 1, 0, 2, 0. So I have to check if all of these are equal. So in the R3 equal, you can do 0, 0, 1, 0, 2, 0. And if someone is 1, you have to pass the respective. So like 0, 0, 1, 0. So basically, this is the ID to the image views, right? Remember? IV underscore 11, which is like this one, right? IV underscore 11. So basically, to a one method, you have to pass all the XML IDs here. So return true, false. Now, actually, yeah, that's it. Only you have to check, are those three equal? And you have to do one. Now, let's do the same for vertical 2. Looks like still no questions. Any questions, I'll be happy to answer those. Vertical 2, let's see what vertical 2. This is vertical 1. Then our next one will be vertical 2, which is 0, 1, 1, 1, 2, 1. 0, 1, 1, 1, 2, 1. So head back over into our things. Check if 0, 1, if 1, 1, and if 2, 1 are equal. If they are equal, then you have to call 1. And what are the winning combinations? Style number 0, 1, our image view 0, 1, our image view with the ID 1, 1, our image view with the ID, oh, I made a mistake here, 0, 0. Oh, I didn't even do this. 0, 0, 1, 0, 2, 0, not 2, 2. Now here the winning combination 0, 1, 1, 1, and then 2, 1. Right? So basically we're checking the board, and if the boards are equal, so this boards are 2D array, so hold Control and click on it. It takes you to where it's defined. Basically, or scroll up basically. So it checks here with the two indices, it checks if they are equal, and if I'll scroll down to horizontal, we are doing vertical 1. So if these three are equal, R3 equal will return true, and then we enter the if block, and if it's 1, if it entered the if block, it means to be 1. So call 1 on the three winning combination image views. The image views with these three IDs are part of the image view, are part of the winning combination. And if it's 1, then return true, right? So boolean, it returns true. This return type is basically it returns if you won. If vertical 2 gives a winning if it gives a win, then it returns true. If vertical 2 doesn't return a win, it just returns false, because the if block will not be encountered, so it returns false. Well, anyway, let's do our same for vertical 1 is done, vertical 2 is done, vertical 3. Vertical 3. Now let's head over to, so this is vertical 1, this is vertical 2, this is vertical 3. So what's it? 0, 0, 2, 1, 2, 2, 2. 0, 2, 1, 2, 2, 2. Let's do that. 0, 2, 1, 2, 2, 2. If on the board all these three tiles are equal, then you have to pass one, you have to pass the respective XML IDs of the corresponding image fields. So here, vertical 3. Let's do the same for diagonals 1 and 2. There are only two diagonals, major and minor. Right? So in math it's called major and minor. For a matrix, matrix, I think that's the correct grammatical thing. If Christoph, my friend Christoph, will be there, he'll probably be like he's a really good English buff. He knows his stuff. Well, vertical 1, 2, 3, diagonal 1. Let's check what are the things in diagonal 1. This is a diagonal 1. So 0, 0, 1, 1, and 2, 2. 0, 0, 1, 1, 2, 2. And the corresponding here also. 0, 0, 1, 1, 2, 2. So diagonal 1. Copy this lines of code for diagonal 2. Diagonal 2. Now let's check in diagonal 2. So it is 0, 2, 1, 1, 2, 0. 0, 2, 1, 1, 2, 0. Let's do 0, 0, 2, 1, 1, 2, 0. 2, 0. So if we ever get a winning combination from diagonal 2, which is like this one, then it'll return true, else it'll return false. Well, that's it. That was our, we only have one to do here. And let's create these methods. So very good progress. We completed step 3. There are 6 steps, basically. To save the changes as we've done before, git add dot. The changes aren't saved now. You have to commit those changes to your local repository. You have to do git commit -m, any message basically. My work for step 3, sure. And it saves, like it checks what all of the differences and it saves those changes. The green should disappear because now it's changed, saves. So very good. So now you have your. So now if we ever call any of these like horizontal 1, horizontal 2, horizontal 3, vertical 1, vertical 2, vertical 3, diagonal 1, diagonal 2. If we ever call any of these methods, and if we ever get true from any of these methods calls, that means somebody has won. So that's the main idea behind this. We split all the 8 winning combinations into separate methods for each. So now let's head over to step 4. We're getting there. So yeah, on our local, we have only had step 1, step 2, step 3 starter code. Let's head over to step 4 starter code. Check out as the same process, click OK. So it creates a new branch in our local called step 4. Now if you notice, it replaces with the solution code. So if you ever like, I'm feeling bored, I don't want to do step 3 now, I'll do it later when I have time. Just save your changes and click on step 4 starter code, because the solution code from step 3 is already there. So you don't need to complete these steps in order, basically. It's recommended, but you can complete it in any order. Now, good. So we have horizontal 1, horizontal 2, horizontal 3, vertical 1, vertical 2, vertical 3, diagonal 1, diagonal 2. Good. Now, if you notice in check 1. So currently we did these 8 helper methods. These didn't do anything. Like it just did a small component of what we actually wanted to do. Check 1 is our main method that will actually check if somebody is won. So let's look at this. So here we have a switch Yes, Rohan, we finally got something that is good. Yes, switch is very common. Switch, and you pass a tile ID. So remember when you do check one, you pass this ID here, view.get ID, which is of the form r dot like the XML form. So this ID variable passed here is of the XML form. So we do switch and then we check. If the tile that was clicked was 0, 0, then you have to only check horizontal one, diagonal one, and vertical one. What does that mean? Let's see. If this was clicked 0, 0, then only check vertical one, horizontal one, and diagonal one. You see this? You don't need to check horizontal two because you can never win with this by pressing here. So you don't need to even check this. You see? You don't need to check this. You don't need to check this. So you only need to check any one of these. And we put this or. So if any one of these returns true, then this whole expression, Boolean expression, return true. What is the false of true? Like the negation of true is false. So if somebody has won, that means if any of these three methods return true, what is the opposite of true? False, because of the exclamation mark. Then is board active will be false. So board will be deactive now. So once somebody is won, you can't play the game because in our on tile click, we checked, right? If the board is inactive, just return. Don't even do these lines of code. See? So now the code is starting to make a little more sense. I hope. I hope. Yeah. So if there are any questions, feel free to put it in. So far, no questions. So, well, I mean, I recommend like make most use of this thing, this live thing. Well, it's fine. Yeah. So now this to do basically says that whenever check one is called, we only are checking for these three tiles. But what if like the other, like we only check the horizontal 0, 0, 0, 1, 0, 2, 0, 0, 0, 1, 0, 2. Now if you do the same for these six tiles. So let's do it. Paste r.id.iv underscore 10, which stands for this one. So if this one is clicked, we only need to check vertical one, horizontal two, and that's it. Because no other combination is affected, right? Like this isn't affected by what you do here, right? So let's do it here. So here you have to only check is board active equal to not off. What? As you mentioned, vertical one. You see, that's why we divide it into separate methods. So it's so easy now. Vertical one and horizontal two. So vertical one, horizontal two. So this tile is only in these two winning combinations. So only check those two. And break as usual is r.id.iv11. Colon is board active is equal to, let's check. For 1, 1, this is a special case. So I have to check vertical 2, horizontal 2, diagonal 1, and diagonal 2. So I have to check 4 cases. So this is something new. So vertical 2 or horizontal 2 or diagonal 1 or diagonal 2. So vertical 2, horizontal 2, diagonal 1, and diagonal fly. Let's apologize for that. Diagonal 2. Yeah. So we checked all of them. If we get a winning combination on any of these, like if any of these 4 winning combinations uh, has equal stuff, has equal tiles there, any one of these methods will return true. The opposite of true is false, and uh, opposite of true is false. So the board will become inactive because is board active will be false. Good. So I think you must have understood this and how we. If not, again, always open for questions. Now we did for the center one. Let's do IV underscore 1 2. So is this style? It is vertical 3 and horizontal 2. Right? You can take your time to think about why we're doing this. Any questions? Yeah, this panel is open to questions. Always welcome questions. Vertical 3 and horizontal 2. Break. r.id dot iv underscore 20 is this one. What's the thing for this one? It is vertical 1 and horizontal 3 and also diagonal 2. So this is diagonal 1, major diagonal in math, and this is the minor diagonal in math, which corresponds to 2. So this is diagonal 1, this is diagonal 2. So vertical 1, horizontal 3, and diagonal 2. Let's check. Vertical 1, horizontal 3, diagonal 2. Great. Let's do it for our last two tiles. 2 1. 2 1 corresponds to this one, right? 0 1 2, and from here 0 1. So 2 1. If you check vertical 2 and horizontal 3. Vertical 2 and horizontal 3. Let's do this. Vertical 2 and horizontal 3. Next, our last tile, r.id.22. Is board active is equal to not. That's this one. So this one, vertical 3, horizontal 3, and diagonal 1. So vertical 3, horizontal 3, diagonal 1. I hope it's understanding that. Vertical 3, horizontal 3, diagonal 1. And the inefficient way to do all this, it's good to have all these switch statements. Because at one particular time, we're only checking 3 winning conditions. 2, 3, at max there are 4. But in the worst case, is you can check all of them, which is inefficient, right? So data structures and algorithms, that's what's the class. I mean, that's the name of the class here at LSU. But all colleges have a similar class, like data structures and algorithms, where they teach you like big O notations and time complexities. Basically, how to make the least time, like how to choose an algorithm with the least time complexity. So all that. First, Dr. Shah, amazing, and Deepak taught us really well. And well, uh, if I'm advertising for them, I better need the money. I'm going to email them right now. On this show watched by over 20 people, I advertised your names. I need my commission. I'm just going to email them right now after the show. After this, I'm going to email them. Well, so this is the good thing. We only checked minimum number of winning combinations, and our to do is done. So whenever a tile is clicked, check one is called, and depending on what tile is clicked, a limited number of conditions, winning conditions will be checked for equal, like if all the tiles have the same thing, and if at all they have in any of these, inside individual ones, it calls this method called one. Oh, which is what you have to implement in this step. All right. So quickly look. All right. So now here, yeah. So when something is one, if you notice in our, let's head over to our screenshot. If you notice, whenever something is one, the other tiles become translucent. So let's see. Let's get to a winning case. If you notice in the examples, I only made LSU win. So yeah, this become translucent. So basically what you have to do is when one is called and the 3 winning tiles are passed here, basically what you have to do is all the other tiles have to become translucent. Set its alpha or opaqueness. Set the alpha or the opaqueness to 0.4, which is not, so it goes from a range of 0 to 1 opaque. So 0.4 is like slightly translucent, like 40% translucent basically, or 40% opaque, and 60, yeah, 40% opaque, and yeah. So that's our plan. So how do we do it? Let us first create a list of all the image views. Name it image view IDs. It's a new int array. And here's how we initialize this in Java. So you can do r.id dot iv00. Error here. What? Yeah, I think I can do this. It's an integer. Good. So here you have id 0001. Basically, as the to-do says, create an int array with all the XML IDs of with the XML IDs of all the tags. Grammatical error maybe with the XML IDs of all the tiles. So basically, that's what we're doing now. The XML ID, so 000102, right? How are we getting this? Quick question. If you're following along, this is the IDs for all the image views in XML. It seems confusing. It's not at all confusing. I mean, it's always overwhelming at first, but trust on this. Give it some time, and I'm confident you'll figure it out. You'll get it. So, and ask me questions too. I mean, um, make the most of this chance. But r.id dot 10, r.id dot 11, r.id dot 12, r.id dot 20, r.id dot 21, r.id dot 22. That's the first thing. Second to do is iterate through all these image view IDs. So go through all the tiles, and if the tile isn't in our winning IDs combination, make it translucent. So instead of doing like for I is equal to and so on and so forth, we can just do a for each loop. So in Java, we do it this way. Int, like let's just call this int image, int style, image view IDs. Basically, it iterates to this array, and each of the each value within that iteration is given in tile. So for each loop, now int tile image view IDs. Here, yeah, you have to check, right? So how do we check it? You can do if tile is equal to string ID is 0 or tile is equal to string ID is 1 or tile string ID is 2. If it's equal, oh sorry, if it is not equal, because if it's not in the winning combination, then we have to make it we have to make that particular tile translucent. So here's how we do it. Now we have tile which is of the type XML ID here. Quiz question. Now here we have to get the uh, Java image view corresponding to this ID, and you have to call dot set alpha and pass in 0.4. So how do I get that image view here? So if you are paying following along, or at least you can give it a try. The reason why we did this hash map is because of this. So look at this hash map called MID tile map. We have linked all of our XML IDs with our image view. So instead of doing long switch case statements here, like switch, I'll show you what I mean. Like switch tile. This is a long cut. A case r.id dot iv0. So if that particular tile is 0, then you have to do miv00 dot set alpha and 4 break or 0.4 maybe, or what's it? Float. Just typecast it to float because by default decimals are doubles. So just typecast it to float, and then there'll be case r.id dot miv 01 miv01 dot set alpha float 0.4. Now, something to note here, if you have like found some pattern here, basically this whole part is the same. The dot set alpha. For all of them, they're going to be same. The only thing that changes is this and this. Like this Java image view, it depends on the XML ID that was passed in tile. So what if there was a way you can just map that? And that's why we did that hash map. So now in this one line of code, MID tile map that has an integer and an image view, tile map.get. Now here you can pass in tile. So it sifts through all that, the huge key value pairs, and it checks it with each ID. No, like I'll show you how. So like this, let's say if we pass in r.id dot iv underscore 21. No, 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 no. Yes, 21 match. Then it returns us this integer array. Oh, sorry, here this 20. It returns us this image view. Now all you have to do is whatever is returned. So scroll all the way down to our one method, one or to do three in our step 4 starter code. Here, where is it? Here. This whole portion will just return the correct image view. That's called dot set alpha float. So instead of writing multiple switch cases, you have to write nine cases inside that switch case block. In just one line of code, you did that because you already did the mapping beforehand. So, well, that was what it is. Any questions? Always. I think if you put a meter of how many times I've said that, if I can get $1 for every time I've done that, I could probably pay my college fees. Yeah. Because I don't know one's asking questions. I really don't know how the folks are taking to. Well, I'm trying to do my best. And if there's any questions, I'll be happy to answer them. If I don't get, then well, sure. So now in one, so whenever something is one, what we do is we sift or we iterate through all the tiles. We check if the tile is in part of our winning IDs. If it is not part of our winning IDs, then we set its alpha to 0.4. I think one thing I should have done is at each step I should have ran the app because so far you haven't even seen the app. So, well, let us because our to do 3 is done. You know what we'll do? Oh, not this. Head over to a terminal. Let's save the changes. Because whenever you want to shift branches, you have to save the changes. So dot add git commit -m my work for step 4. Save the changes, and now it will go. Basically, I hope at least you have done it because I totally slipped my mind. Because these to-dos were like pretty organized here. So if at any point on our local branches, we can head over to starter code step 1 checkout, and it'll give us to that stage, right? That stage. You can run the app on our emulator. So here's the completed app. Oops. Yeah, LSU went there. All right. I don't want to make Alabama win in this sample thing. Well, yeah. Yes. At stage 1, we only did this layout. 9, and when you click on it, nothing happens because on tile click was nothing. You have to do that. One other thing is, if you notice in the preview pane, and if you notice in our app, so you have these LSU things, you don't have it. So that's something that I don't talk about, but let me briefly introduce that. Is this thing of tools. So each image view, if you notice, each image view has two SRCs. SRC stands for source. So currently the source, an Android source, it is this blank transparent square. But tools source is the LSU logo. So basically what it says is that in the actual Android app, show a blank transparent square, right? Because in an app you want to show transparent square. The thing is, if you don't have this tools line, in our preview pane while developing the app, we see this transparent square, and our whole from here to here will be transparent. So we don't know how our app looks, right? We need some preview. So you can do tools SRC instead of Android SRC. You can do LFC logo. So in our preview pane, it will show whatever is there in our tools SRC in our preview pane. But in the actual app, it will actually do whatever is there in our Android SRC. That's just something to note. And now we're very, very close. So we just have last step 5, and we are very close now. Step 6 is very short, so we'll be fine. So I hope at least till here, at least the general part of it is clear. Let's run step 2 starter code. Okay, done. Check out step 2 starter code. Let us restart the app. Let us see at this step what do we have. So at step 2, yeah, our app now shows these tiles, but if there's a win like this, nothing happens, and it even accepts. Yeah, so that's the thing. Let's check step 3. What we do in step 3. Check it out and run the app again. So that's how version control is so helpful. So it sets like all the code to however it was in that step 3. Now let's see what we did here. So here, yes, here also it won't check if someone has won. Alabama's turn. Let's do it here. LSU's turn. Alabama's turn. LSU won. Yeah, just only one LSU who win in this. Step 4. Now here is where we have actually done the check win. So once let us verify if our logic is correct. So what do I mean in step 4? What do we do? Remember, we coded this one where it cycles through all the image views, and if an image view is not in the winning combination, it sets it to translucent. We also did the check one method where it checks those corresponding winning combinations, right? So now if our app is coded correctly, oh, so there's some mistake here. So this should actually be opaque. So we did some mistake here. Let's see what we did. Get tile. Yeah, for each of the tiles, winning IDs. Are we passing the correct winning IDs here? Okay. So this was winning in vertical 1. So 001020. The code seems fine. It calls 1 with 001020. We cycle through all of these. The tile is not equal to correct. Set this. Set alpha. So again, so there's some small bug, and to save time, what we can do is actually here also there's some functionality to do that. You can step 4 starter code, step 4 solution code, click on it and click compare with current. And then in step 4 starter code, compare with current. Let's see. So it shows you all the differences. So again, it could be a little you can see the differences here. Let's check. Well, yeah, I'm pretty sure I'm confusing people. There's a small bug there which we have to fix. So change this to step on GitHub, change it to step 4 solution code. And under app main, so app src main and Java, this whole thing, main activity.java. Let us scroll all the way down to our one. Are we forgetting something? So, all right, so let me just restart the app. What exactly is happening? 2.9, all right. Everything goes, IDs, style. image view IDs. Yep, effect embedding IDs. So one very quick thing that we can do is, and we won't spend too much time here, is in the log statement, let's just do so this is a good sneak peek into how we could troubleshoot some of our errors here. There's a small bug that we can't find. Let's not try. Let's just do this. Let's restart the app so we can see how many times this method won or how many times this if block is run. So head over to our run pane and let's do a winning combination. 7, 8, 9. It's run 9 times. So if anyone's seen what I'm, yeah, it's not or, it's and. So it's a small error. So now it should work. So we're very close to our end now, the end of our, and so now the winning combination will be opaque, and only the non-winning combination will be translucent. So now we can remove the debug statement, and so very good. So we have done this. You can save the changes now. Head over to terminal, git add dot git commit dash m, right? And here you can say like fixed all turning translucent color. Just any message basically. All right, good. And now step 5. So our last few minutes we can give to step 5. Step 5 static code. Let's check out as. Let's download it from our remote Git repository. And oh, it's done. Good. So now we can head over to our to-dos, and we have a couple of to-dos here. Good. Now here is our reset app. So when there's a win, so we haven't implemented it, but here there'll be a button called reset. When you click on it, everything should be deleted and the whole board should come back to normal. So let's see how to do that. So again, I'm just following the to-dos here. So when you reset the app, if the board is inactive, make it to active, right? Because now it will accept inputs or accept input. The current team, so m turn is equal to team.lsu. What does this mean? Let's say if it was Alabama's turn when the last play was played. So, like when the game is always starts, LSU starts first. So we are resetting everything to the defaults. The board must equal whatever it started with. And minimize this. So we can copy these lines here. Control C. So basically board, it started with all empty. So when reset is clicked, it must again. So reset is the last method if you're scrolling and want to find it out. Just type in here new int. This should work. New team and 2D array. So we reset board with empty. So if there were like team.lsu in the top left, everything will be reset to empty. Good. The fourth one is create a list, which we did before itself. So just this list basically. Control C, Control V. So we have this list of all the IDs. We have the list of IDs of all the tiles of all the image views, right? 00, 01, 02, all the way till 22. Now I have to iterate through all of them. So for just like last time, tile image view IDs. Now here, set the alpha of all of them to 1, right? Because when you, like now, if you press reset, the alpha of these two image views, I mean of all these 6 image views are not 1, they are 0.4. So they are translucent, not opaque. So set all of them to opaque. Right? When you reset the board, you have to set all of them to opaque. How to do that? M id tile map dot get, because tile is of the type the XML this integer dot get tile. So it gives us the image view associated with it. Dot set alpha, just like last time, but instead of passing 0.4 now, we pass in 1. Right? Also, all of the images here, it should be now blank transparent image, right? When you click on reset. So if there's any confusion, be sure to ask me. MID index map dot set image resource dot get file. So we get the corresponding image view. Now set image resource, control space. Oh, I took the wrong one. The tile map dot set image resource. Now here you can pass r dot drawable dot blank transparent square. So that's what happens. So now you have this reset method. So you can create a reset method here, a reset button here at the bottom, and link this method as the on-click method, as we discussed in weeks 1 and 2. Or you can do a reset method here in the action bar, which is something that we will. So if there are any questions, we'll do the questions first, or the action bar we can do next time, because that involves some extra things, and I'm sure like people have already. I don't know. Many people must have not. There are many questions, or maybe the audience is not very active today. So if there are any questions, we'll answer the questions first as first priority. If not, then we'll discuss on how to set the reset button first. So assume there aren't any questions. Cool. So I'll move forward then. So first of all, we have completed our reset app. So we have completed all the 7 to-dos here. All the 7 to-dos. Good. So now you can save the changes. Again, terminal git add dot, then git commit dash m step 5 completed. Message doesn't matter really. Step 5 completed. And now the green stuff should go because changes like they are saved. And now we can head over to, we have downloaded all the way till 5. Download starter code 6. Check out as. Okay. Oh, the to-dos are still there, but well, accidentally I kept it there. Now if you do this, there's only one to do. It's very small. You have to add this. I mean, they look like 5, but it's basically just one thing. Is this add an image view. So if you notice in the completed app, there's this. How do you get that, right? How do you get that bold? Like this what is it? Like the hash sign. How do you get that? Well, it's actually an image that is already downloaded for you. It is tic-tac-toe background. It is this image here. So if you just include this image in our Android Studio app. So I'm currently on step 6 starter code. Here, under all the 5 to-dos, add an image view tag. Now here, towards the end, is we are actually doing a little bit of actual XML coding. So earlier we just did copy paste, but now at the end, once you're a little confident, we are slowly starting to write our XML code. So let us write it here. Our opening tag. Now image view is a child tag, so we're going to use the self-enclosing. Now, no problem, I'll show if it could be confusing. Remember, there are 2 tags, opening plus closing, that's our first one, and self-closing or self-enclosing, that's our second one. So the first one, opening and closing, use it for parents. Opening, closing for parents. But now we have something like an image view. So use the self and closing. Right? It starts with the greater than less than sign, ends with forward slash and the greater than sign. So start with here, image view, and oh, let me go slowly actually. Open the thing, image view, type it in here. Autocomplete is very good. It gives you everything. Click enter. Now, if you notice, Android has already prompted you to enter width and height because these are required properties. So for width and height, you can just type in 0 dp, or you can type in just 100 dp for trial, enter, and it takes you to the height 100 dp. And now to close this tag, just type in the forward slash. And it closes this tag. The closing, self-enclosing thing, right? Right. We have an image view that's here. You can see it. Let us add source to it. So instead of doing tool source, because in this, here you can type in, oh, I'm going too fast. Let me slow down. So you can type in tools colon src is equal to, and then you have to pass in. So this is the general format. Something colon, then the attribute name is equal to, then attribute within the, like the quotation marks. Here you can just autocomplete is very good. You can type in here background, and you can see this tic-tac-toe background selected. You get the background here, right? Now this is small. It's just 100 dp. We have to extend this all the way to the edges of the board. How do we do that? Using constraints. So in design, you can actually select this, and you can constrain this to the top of the board, bottom to the bottom of the board, right? So I'm not doing, oh, I actually don't want to do this. Let me delete it. So now let's see our text. There are only 3 attributes here. Now head over to design. All right, we'll end soon. The design here. So here we hook the top of the image view to the top of the board. Head over to text. You notice this Android automatically added this XML for us. So it basically is of the type like constrain the top to the top of table layout. This is this table. Notice this whole table. So now, as I mentioned, we're not going to use a design editor. Let's use the text editor here. So now here you can do, you have to hook the left to the left of this table, right? So you can type in start to start, and autocomplete all it just gives you this option. So no need of typing the whole thing. Click enter, and it autocomplete is so good. It completed everything for you. Now here you have to just scroll down until you find table layout. So left is linked with this one, top is linked with this one. Now the end, so start and end is equivalent to left and right. So the end to end of table layout. So this should be linked here, table layout. So you notice now it's centered because it's being pulled from the left and from the right by an equal amount, as we discussed at length in weeks 1 and 2. And now bottom to the bottom of this. So bottom to bottom. So bottom of the current view to the bottom of some other view, right? So click enter and pass in table layout. So how do we read this? Like constrain the bottom of the current of this image view to the bottom of the table layout. Constrain the end of this image view to the end of the table layout. So why are we using text? It is very easy because autocomplete is very fast. So let me delete this line. So when you are like, you have done it many times, you can just type in bottom and scroll down bottom to bottom of table layout. Here in the dragging, I mean, it's sometimes beneficial, but you have to drag, and then let's say if you change some attribute, you have to scroll all the way, right? Here, if you just know what attribute you want to change, you can just type it in like src, right? So on and so forth. By the way, tools src means the image will be visible only in the preview pane, but we want the image to be displayed in the app. So let's go to Android src. And now, since you want this to match the edges of the board, to match constraint, so instead of 100 dp, change it to 0 dp, which basically expands it to dimensions of the board. Now, if you notice, we want our the hash sign to stretch all the way to the top, left, right. The thing with this that you've done here is the image view container has gone to match constraint. So if you go in the design editor, image view, match constraint, basically match constraint means 0 dp is what I'm trying to say. So, but the thing is the container has stretched all the way here. If you notice this is a bit taller than as it is wide. It's like a rectangle, a vertical rectangle. But the image, if you see here, blank transparent, I mean the tic-tac-toe background, this is a square image. So that's why you'll get this top white portion, the bottom white portion. Quiz question, I mean, let's see if you're, basically it's from weeks 1 and 2. How do you stretch this all the way to the edges of it? If you don't know, even the people who attended weeks 1 and 2 may not know, it's fine. Because as I mentioned, if you always forget something, you can just type it in here. So go to this image view that you have next to the to-dos. Anywhere, just enter a new line basically. Between the opening and the self-closing tag, type in here scale type, enter. Get all these options here. Fit XY. It distorts the aspect ratio and it fits the edges of the container. And now you get our finalized app. Let's run this app. So we complete this app in steps. We are towards the end, and now our app works. So the reason I didn't do the reset button is because already I don't know if people are even like understanding this or yeah. So I just want to introduce a totally new concept that we're anyway going to discuss at length next time. So, but in a sample, if you're interested and want to go beyond what you've covered, in the master branch, we have. So I'll save the changes here, and we almost are like just 1 or 2 more minutes, and we are done. So git add save the changes, git commit -m added background. And now whenever you finish the change, now you can switch over to master branch, check out. And if you notice the master branch, and now let's restart the app from the master branch. So that has, so if you want, you can refer to the code. That'll have the reset button. So now you can reset the board. Yeah. So yeah, that's our thing. That's our time. And if you didn't follow along with the video, not a problem at all. Everything is very detailed in these the GitHub repository. You can clone it and compare. And if there are any questions, you can get in touch with me too, like directly, or ask now in the thing. And yeah, I hope it helped you in some way. Yeah. So if there's any questions, we can answer it now. So.
Hey, Rohan, looks like we don't have any questions.
So if Yudesh is
Hey, Rohan, can you hear me?
but otherwise, yeah, it's done from our side. You can code along using the starter code and the to-dos and the very detailed documentation. You can go through that. And if you are stuck at any point, you can refer to the video there. It's going to be on YouTube and on Twitter live, I believe. Yeah. Is there some error on my side? So, because I'm not hearing from Malaysia, we don't have questions. All right. So, yes. So, yeah, that's it. That's it. And so I hope this helped you in some way. Stay safe, take care, and have a nice rest of your day. Thank you.
Hey, Rohan.